What's up, everybody? This is Eddie from FlexArm and Flex CNC. We are coming at you live via YouTube live stream from our beautiful facility right here in Walpock, Ohio, and we are absolutely pumped because we have an amazing demonstration for you today. We're going to be launching the latest and greatest machining solution to help you drill, mill, tap, and mark all those structural steel profiles. But before we get started, you'll notice on this side of the screen there is a chat box. With this being an interactive and engaging type of live stream, we truly encourage and anticipate each and every one of you to place any comments or questions you have in that section there, and you never know, you could be lucky. We'll pull that bad boy up on the screen and answer it in real time. Looks like Zach Albert says showtime. My man, Zach is on top of it, so we definitely appreciate that as well. You'll notice on this part of the screen there is a subscribe button. Please hit that subscribe button, hit that bell so you can turn on those notifications for all the amazing content we'll be distributing your way in the near future. And last but certainly not least, give us a huge thumbs up. So as we get started, we're going to be introducing the one, the only, the FlexBeam. This is our very own horizontal machining center with up to 40 inches of movement on that y-axis. We're looking at 50 plus on the X, rocking an 18 horsepower motor and pushing out up to 3,000 RPMs. But here to tell us the what and the why behind FlexBeam, we have our very own president and owner of Flex Machine Tools, my man, Nick Kennedy. Get over here, you stud.
Eddie, hey guys, welcome to the stream today. We've got a great event for you. Right now, Eddie gave a great introduction, so I think he explained the machine really well. But so what we're really excited about today is launching this, because what we've done is we've taken a lot of our components from our vertical machining center and applied that same precision to our structural steel processing machine here, where we're going to be machining I-beam, tube, pipe, channel, plate, you name it. With the modular design too, we're able to build this thing as long as you would like. And with this design too, you guys will notice they have a great presentation, but it keeps a very compact footprint, giving you a ton of length. So super excited about it. This machine is going to give a lot of value. It's the best value for the money on the market to any small to mid-sized fabricator out there or shop looking to do more structural machining. This is it. So like I said, super excited about the presentation. I'm going to lay it over here to the experts and let them show you what we've got going on. So
There we go. Well, thank you so much, Nick. I appreciate
Thanks,
it.
Eddie.
So, this demo started. I got my CNC in-house specialist, my man Aaron over here, man. So Aaron, tell us a little bit about what we're going to be doing today.
So today we got our 12-inch H-beam up here that we're going to drill some holes in. And just to kind of give you a quick overview of how this machine is laid out. So we have an X-axis laser here on the side of the machine. So as far as getting your parts set up, the machine itself is going to find the edge of your part. So there is no probing or using an edge finder to find the edge of your part. The top of the machine bed that you're looking at, that the part is sitting on, is going to be your Y0. So your laser is going to find your X0. The top of the machine bed is going to be your Y0, and you can see the little black stops that you're pushing the part up against. The front face of that stop is going to be your Z0. So as far as setting the part up itself, super easy. And I'm going to go right into drilling the first set of holes here, and we'll get this demo rolling. So here we have the machine finding that X-axis with the laser. And here I've got our a structural drill from Allied. Here we have the hydraulic foot coming down. This is going to act as our clamp to hold the part in place as we drill our holes.
Very, very nice. So Aaron, on that cycle time of those 4 holes, what were we looking at timing-wise, man?
So we're only looking at a couple minutes here, and you know, I had to start with the first tool that you're going to use in a program. Stays in the spindle. So with that just being a one tool program right there, you're looking at just about a minute to drill those 4 holes. The Ally drills are really special when it comes into to cycle times. We got the Gen 3 structural style drill, which really kind of gives us the best feed rate, which gives us the best cycle time. So yeah, it was a pretty quick cycle there.
Yeah, there we go. It looked like it was relatively quick, and for those of you joining in, I'm sure the machinists out there, it's definitely got that good machining smell, man, the one we all love. So, no, which is great. And another thing to note, even though we're utilizing one tool, we can hold up to 6 different tools on this machine alone, given its wide variety of capabilities. So, anything else we need to know either about the drill or just the general operation, Aaron?
No, I mean, what you saw there was a pretty easy example of how this machine's going to run, whether you're milling slots or drilling holes. I mean, the machine itself is built for simplicity. We do have the through spindle lubrication. We do have exterior and interior. We don't use a flood coolant type of application. So we have a lubrication container reservoir in the back of the machine here that runs the fluid through the tool or externally on the hose to get that lubrication to the tool. And you saw the hydraulic foot. As far as clamping goes, if you're just drilling some simple holes or even milling slots, that hydraulic foot is what holds your part in place.
Okay.
So any type of H-beam, I-beam, tube, channel, anything like that, your hydraulic foot is going to be the application that holds your part in place. You can put like an angle plate on here, bolt some vices to it if you want to machine some flat bar, but that hydraulic foot is what does all of the work holding.
No, very solid. And being able to have the capability of moving that 24 inches all the way up to 40, I mean, that gives you a lot of variety and range and being able to process that specific plate. So I know no machine, or I guess the machines in general, they're only as good as the programming essentially that they run off of. So Isaac, if you wouldn't mind pulling up a little bit of that B-roll, and then Aaron, you want to talk to us a little bit about the software that we're going to be working with to run this machine.
Sure. Isaac, if you can actually roll into the team viewer view of the control here. So what you're looking at, you see these different tabs up here at the top. This is the general software of the machine itself, NJ Wind. So we have these different tabs up here, the alarms tab, which shows you any issue that you have with the machine. You'll get a red X up in the top right hand corner, and it'll explain to you what that alarm is and where at on the machine that you can find that issue. The next tab that you're looking at, the reference point, this is how you zero out your machine, which is pretty standard across most machines out there in the industry. The machine has to find that original 0 point. The next tab is the programming tab. This tab here is where you will load, save all of your G-code ISO programs, and I will touch base into this a little bit more with the software that is built into NJ Wind Drill Cam. That's the software that we use to program the parts. But here, the next point, the 0 point tab, this is where you can set all your different work zones. I mean, you saw the 40-foot bed, and you can put all kinds of material, different materials, or if you're working with a 40-foot piece, you can put the whole piece up here. But this gives you different work zones, areas along the machining bed that you can set your work offsets. Next is the tool tab. Here you're looking at our tool library. As you're doing different parts, different materials, you're using different tools, right? So you got to create your tool based off of what material you're running and apply the feeds and speeds that work well with that material. And as you go about programming, all the feeds and speeds and everything that you have entered in with that tool stays with it. Here in the manual tab is where you do all the manual movements of the machine, moving your X, Y, Z axis. You can move that hydraulic foot up and down, do any manual tool changes here. But next, Isaac, if you want to go ahead and roll that video, I'll kind of go across the drill cam, which is the programming aspect of this software. So what you're looking at here, we're going to start loading a new part, and really we're going to draw our own part. So here you got the different profiles of material, and once we select a material, it's just putting in what sizes, that you're going to put into that software, the part that you're using. You can create your own types of materials. This is that drop down box that you're looking at there. So there you can see the part. We have a 4x4 tube with a 1/4 inch wall. The next thing that I'm going to show you is the tool library. Here you've got main groups. You've got drilling, tapping, milling, counterbores, taps, and then you can create subgroups along in each category. But this is where you would create all of your tools to use within your software. So first we're going to do some easy stuff. We're going to drill some holes first. So here I just have to select which face of the part I'm going to drill those holes on. So I'm going to select that face right there, and we got the diameter of the hole that we're drilling. If we want to add a chamfer to it, we can. Here we're just going to drill a hole. So the next section is what tool are we going to use. So here's the subgroups I mentioned earlier that I had previously created, and this is the ally drill that I'm going to use to do this. Now when I talked about creating a tool and importing all of that feeds and speeds information, anytime you use that tool, that information always follows it anytime you use it. So here, now we're gonna, basically we told it what we're gonna do, what tool we're gonna use, now we're telling it where we're gonna do it. So this is just me putting in all the information in of where those holes are gonna be located, and you can see there the line at the bottom that tells me where those holes are gonna be. And okay, and here are our holes. So the next thing that we're gonna do is I'm gonna take these first two holes and we're gonna turn that into a slot. So it's just as easy as selecting a profile. Same thing as the drilling, selecting what face I'm gonna do, machine on the part. And the checkbox that you're seeing right there is how deep do I wanna go? It knows it has a 1/4 inch wall. So when I check box that go through, it knows to make sure I go all the way through that wall. Here we're just setting up the different dimensions of that slot. And it's going to be the same process. Once I tell it what I'm going to do, what tool am I going to use? So here again are the subgroups of the tooling, and I've already created my end mills that I want it to use to machine that. Now how I said earlier, how that tooling information follows that tool every time you use it, you can change it. So here I did not input a feed for this tool when I created it, because I can change it depending on the different types of material. So what we're doing next is basically telling the machine where on that part I want to make that slot. Same thing, giving it that whole location of where to start that length and width of the slot. And it'll be as simple, as soon as I hit OK here, you will see the slot. There you see the tool path on the part. So now we have the part programmed. Now we need to put it on the machine and tell the machine where this part is going to be sitting. First thing we got to do is obviously save the file so we don't lose any of this information. And then when we go into our nesting, you will see the entire machine bed here. You can see on the part is attached to my cursors, so when I zoom in, the stops that I was talking about earlier, I can place that part directly along one of those stops that are on here on the machine bed. So once I put my part on the table, I'm going to build my program. So in the build tab, this is where I can tell it if I want to use the hydraulic foot. Do I want to use the X-axis laser to find my part? It gives me my tool list that I have put together for this program. And as soon as I hit OK here, then it's going to provide me with my G-code ISO program that all I need to do at this point is save that onto my USB so I can load it onto my machine. Here's that ISO program that I was talking about. You see the tool change to the end mill. Now the nice thing about this software also is after I get my G-code program, I can also simulate my program. So I know if I'm going to have any machine crashes, if I'm using the right tools, you know, that sort of thing. It's a very handy application to have within the software itself. So here you can see the mill machining out that slot that we made. And like I said, this is just a simple visual for those of the customers out there that don't have the experience with a G-code program, any programming. It's very simple, very easy to use. And yeah, that's pretty much the gist of the programming there.
There you go, man. Spoken like a true expert. And so Isaac, what we'll do, we talked a little bit about the movement. So if you could pull up a little bit of that B-roll, because what we're looking at here with this specific machine when it comes to the movement is on that X-axis, you're going to be moving via a linear rack and pinion. Now, when we move it over to the Y, that movement is actually controlled by a precision ball screw. So we're seeing a little bit here, really of just a general close-up of the inside of the machine, so you can look more at those movement components in tandem with the multiple tool changers that we have, again, available inside the machine. And you're seeing here, this is actually going to be our light curtain that lives along that X-axis. Aaron, can you tell us a little bit anything about this light curtain in general?
Yeah, so anytime that this machine is in automatic mode, when I ran that program before, I have a little switch right here that I can flip from auto to manual. Anytime you're in that automatic mode, that light curtain is active. So as that machine travels, anytime that your operator gets within that light curtain, the machine will alarm out and will stop and keep your operator safe.
Very good, very good. No, a solid demonstration of just general features. So, Aaron, I think we've got one more op that we're going to be able to do today, or what are we looking at, man?
We're going to move on, actually. So what we're going to do next is, I think I'm done with the machining aspect of it.
Okay, okay.
So yeah, just go ahead and take it away.
Good deal. Well, then what we'll at least do is, if you don't mind, let's show a little bit of the travel along that X, if we wouldn't mind, man.
Yeah, and something I don't know if we mentioned before was the pendant here. The pendant helps me as the operator. It has a feed rate kind of override toggle on here that I can control the speed of the machine itself. And this is anytime you're doing any manual traveling, and also when you're running your program. So I've got it sped up here, and then I can slow it down and can really control how fast that machine is moving. And this machine is kind of different than a vertical machine. So you saw the X-axis going this way. The Y-axis is actually vertical, which is different than a vertical machine. That would normally be your Z-axis, where your Z-axis is going into the face of the part this way.
Okay, okay. And would you be able to give just a small example of using the automatic tool changer?
Yeah, sure.
Absolutely, that'd be awesome, man.
So here, this is something that I'm going to do again in the manual tab, because I'm manually changing these tools. So here we're going to put this tool away, and we will grab the next tool. Now every time that you are using a different tool, when you run a program, you need to tell the machine how long the tool is, right? So we're going to do another tool change here. We go orient the spindle. Now what we have here on the side of the machine here, if we can get this into a camera view here. So this is something else that's pretty nice about this machine. This is our tool touch off. And how it works is once you load all these tools into the machine, the pad latches onto the side of the machine bed, and you're going to touch your tools off here, which will tell the machine exactly how long that tool is. So when you run your program, it knows how deep you got to go and whatnot. But it stays right here on the machine, travels with it, and you can essentially touch your tools off at any place that you need to.
There we go. Very good, very good. Well, is there any other items that we should be looking over today, Aaron? I know we've covered a decent amount, man.
No, I mean, I think this was a pretty good showing for the first time, the launch of this machine. We will definitely have more videos to come showcasing more features.
Oh yeah, absolutely. A little bird told me that we might be doing a little bit of milling here soon, so we'll definitely have to see. But Aaron, thank you so much for your expertise. Thank you so much for joining us. Anybody on the live stream, we truly appreciate you. But before we get going, do we have any general questions? Look here. All right, looks like Joe Taylor, how would you fixture plate?
So obviously, Joe, it's going to depend on the size of your plate, but we talked about the hydraulic foot holding on to your parts. But when it comes to a plate or a flat bar, you can take an angle plate and bolt some vices onto the angle plate to set up here on the machine bed, and simply just put your plate into those vices or work holding fixture that you have for that particular part.
Right on, right on. What other, looks like Logan Skelly. Does this machine accept Tekla files?
Yes, this machine does accept Tekla files. Those are one of the types of files that you can use to program in that drill cam software that I talked about. We also use Inventor here, so it will also accept IPT files, NC1 files. So yes, Logan, to answer your question, it will accept Tekla files.
Very good, very good. No, love the questions. Isaac, do we have anything else here, man? My man, Tyler Albert, what is the tallest beam you can machine on the FlexBeam, and do you offer this machine in 60-foot lengths?
Yeah, so the tallest, you can see here as far as length goes, we have 40 foot here, but it is customizable up to really any length that you would like. As far as the height of the part, standard is 24-inch stroke, but we can get up to 41 inches with the y-axis.
Yeah, absolutely, absolutely. And notice, even though this is a standard 40-foot machine, I know we typically put out there the 40 and 50 foot because we see that that's probably the more popular options, but that does not mean that we cannot make machines that are 60 foot plus depending on your specific needs. So a lot of it comes down to the point of being essentially modular, where if at any point your needs increase or you need to be able to process larger steel profiles, we can easily slap that on at any given time. So solid question. Isaac, anything else from the peanut gallery before we put a red bow on this bad boy? Let's get all these questions answered. Awesome. Hey, that was a solid bit of information nonetheless. Really, Aaron, what a stud. We definitely appreciate your expertise. Nick, thank you for joining us. Everyone on the live stream, make sure before you leave today, you hit that subscribe button. You hit that bell so we can keep you in the loop with all the amazing notifications when we are releasing more live streams, and give us a huge thumbs up. Thanks for joining the stream. You keep on drilling beams, and we will see you guys next time.